In 2009, a study from Harvard University examined the top 6 preventable causes of death in the United States. The results included the usual suspects: smoking, high blood pressure, and complications from diabetes. These are the known variables that define our understanding of public health. But the list contained a statistical outlier: the absence of dietary seafood. Public health campaigns focus on the toxic habits we need to quit. This data suggests that the lack of a specific nutrient is as dangerous as the presence of a toxin. Researchers use the omega-3 index to measure this risk. It is a biological marker that tracks the percentage of fatty acids in your red blood cell membranes, serving as a long-term record of your nutritional status. Data from the Fatty Acid Research Institute shows that a regular smoker with a high omega-3 index has the same life expectancy as a non-smoker with a low index. Smoking is one of the most destructive habits for the human heart. Finding a nutritional baseline that can neutralize that specific statistical deficit points to a biological mystery in the fish aisle. There are 3 main types of omega-3s. Alpha-linolenic acid, or ALA, comes from plants like walnuts and flax. In the human body, it converts poorly. However, marine sources provide EPA and DHA, which act as immediate biological currency. These specific molecules, EPA and DHA, are the raw materials the cardiovascular system requires to maintain its structural integrity. For most of human history, coastal diets provided these marine fats in abundance. Our physiology evolved under the assumption of a constant supply. The shift to modern, processed diets has removed this fuel from our food supply, leaving the vascular system without the resources it was built to use. The damage caused by this deficiency manifests in 2 ways. First, cardiovascular disease is largely driven by a cascading inflammatory response within the arteries. Marine omega-3s act as a chemical dampener, constantly resolving the inflammation before it can lead to the formation of permanent plaques. The second mechanism is mechanical. It concerns the flexibility of the cell membranes in the endothelial cells that line your blood vessels. This diagram compares cell walls. Trans fats make membranes stiff and brittle, causing heart attacks. Omega-3s do the opposite. EPA and DHA physically embed into vascular cells, acting as structural lubricants, so membranes remain flexible under pressure. Maintaining an 8% omega-3 index correlates to a 5-year life extension and a 90% reduction in the risk of sudden cardiac death. Regularly consuming these fatty acids satisfies a mechanical requirement for the structural integrity of the human heart and brain. If this biological marker is as predictive as smoking status, why isn't the omega-3 index a standard part of a yearly checkup? Most medical students receive only a brief education in nutrition. Their training focuses on diagnosing and treating acute disease rather than managing the micronutrients required for cellular health. The modern medical establishment is built to treat late-stage symptoms. It is not designed to optimize the biological baselines that prevent those symptoms from appearing in the first place. Because this metric falls outside of standard institutional care, managing your own nutritional baseline becomes a personal responsibility. Most people in modern societies operate at a 4% omega-3 index, which puts them in the high-risk category. Rebuilding your cellular health is an efficient process. Clinical studies show that taking 1.5 to 2 grams of EPA and DHA daily can raise a person from the 4% zone to the optimal 8% zone in 90 days. For those who prefer whole foods, eating low-mercury fish like salmon 3 times a week provides the same raw materials for cellular repair. Long-term survival depends on avoiding toxic habits and actively supplying the biological engine with the specific raw materials it requires.